video, we're going to talk about problems from 12.7, numbers 1, 3, 5, 7, 9, and 11, where we are going to divide a polynomial by a monomial. This is the situation where you don't have to do long division of polynomials. I've already done the video on long division of polynomials earlier, but this is going to be something that makes our lives much easier when the denominator is a monomial. So I'm going to start off with this problem, 14x to the 8th plus 7x to the 2nd divided by x. And what I'm going to do is I'm going to say if I have a plus b over c, that equals a over c plus b over c. I'm just going to split the fractions apart. This also works for subtraction here. So I'm going to split this as 14x to the 8th over x plus 7x to the 7th over x. And we're going to simplify each part here. This is going to be 14x to the 7th plus 7x. And that's it. That's my quotient. I didn't have to do any long division. Now we have 27x to the 3rd plus 36x squared minus 54x minus 9, all divided by 9. So this is going to be 27x to the 3rd over 9 plus 36x to the 2nd over 9 minus 54x over 9 minus 9 over 9. 9 goes into 27 3 times, into 36 4 times, into 54 6 times, and into 9 1 time, making this 3x to the 3rd plus 4x to the 2nd minus 6x minus 1. Pretty nice alternative to long division of polynomials if you know how to do that. If not, that video goes right after this one in the playlist. I just made it earlier because it's something that more people needed help with right away. So I went out of order and did that one first. All right. So this is 12p to the 7th plus 6p to the 5th over 3p is going to be 12p to the 7th over 3p plus 6p to the 5th over 3p. 3 goes into 12 4 times. Take 1p away and be left with p to the 6th. 3 goes into 6 2 times. Take 1p away and be left with p to the 4th. This is 4p to the 6th plus 2p to the 4th. We may not always get the denominator to divide out evenly, which we're going to see here in this next problem. So we may end up with a fraction for one of our terms, and that's okay. Or for both of our terms, and that's okay. Negative 12x to the 8th plus 20x to the 9th over 10x to the 9th. Be negative 12x to the 8th over 10x to the 9th plus 20x to the 9th over 10x to the 9th. So there's going to be an x left in the denominator. I can only take a 2 out. It's a common factor here. That's 6, and that's 5, making a negative 6 over 5x for this term. 10 goes into 22 times, and the x to the 9ths cancel, leaving me with negative 6 over x over 5x, and then plus 2 as my quotient. Now I have negative 25 x to the 7th plus 20x to the 5th minus 10 over 5x to the 2nd, negative 25x to the 7th over 5x to the 2nd plus 20x to the 5th over 5x to the 2nd minus 10 over 5x to the 2nd. 5 goes into 25 5 times. That's going to be an x to the 5th. 5 goes into 24 times. That's going to be x to the 3rd. 5 goes into negative 10, negative 2 times. And that x squared stays in the denominator. This is negative 5x to the 5th plus 4x to the 3rd minus 2 over x to the 2nd. Last one in this particular video here. 12x to the 4th minus 8x to the 3rd plus 7 over negative 12x to the 4th. 12x to the 4th over negative 12x to the 4th minus 8x to the 3rd over negative 12x to the 4th plus 7 over negative 12x to the 4th. Going to give me a negative 1. Then this is going to be 2 and 3 positive because I divided them both by negative 4. So this is 2 over 3x. And then this is going to be a negative 7 over 12x to the 4th. All right. Like I said, I've already done the video from 12.7 on long division of polynomials. That would be problem number 17, 19, 21, 23, 27, and 41. So you can go ahead and find that next in the playlist after this video. And the next video that I'm going to be making is going to be a video from 14.5 for solving equations containing rational expressions. We need to be careful with that to watch out for where the expression is undefined and to check for what we call extraneous solutions, where we can't have a solution that's not in what we call the domain of our function. We'll get there with that video, but that one is a little bit trickier than just solving for linear equations. So we'll come back and talk about that one next time.